Good morning, my dear students. In this particular video presentation, as usual, we'll discuss some more problems meant for JEE or any competitive examination for that matter. As usual, before going into the problem, I'd like to discuss one particular proof, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. The proof goes like this. Just see here. I'll take a minus x equal to t. Now for minus dx is equal to dt. Now for dx becomes minus dt. When x is equal to 0, t will be is equal to a. When x is equal to a, my t range, t will be 0. A minus a becomes 0. Therefore, integral x is equal to 0, x is equal to a, f of x dx. Integral x is equal to 0, x is equal to a, f of x dx will be automatically is equal to these are the x limits. This can be written as t is equal to a, t is equal to 0 of a minus x is nothing but t, f of t, sorry, f of x is nothing but a minus t, sorry, x can be replaced by a minus t. I started with f of x dx. I can start from RHS also. This is a minus t minus dt, which is minus of minus integral 0 to a f of a minus t dt. If upper and lower limit or interchange, I'll get a negative sign. Therefore, we get it to be integral 0 to a f of a minus x dx, since x comma t are dummy variables. Here, this is not because of the substitution. The meaning of dummy variables is f of x equal to x square, f of t is equal to t square, f of u is equal to u square, f of y is equal to y square. Everything will give you the same parabola. Therefore, if I replace t by x is because of dummy variable property. So let me repeat. Put a minus x equal to t, minus dx becomes dt, dx is minus dt. When x is 0, t is a minus 0 a. When x is a, t is a minus a, which is 0. For x equal to 0, x equal to a, f of x dx will give you t is equal to a, t is equal to 0, f of a minus t minus dt. Minus of minus 0 t, f of a minus t dt. If I interchange the upper and lower limit, we'll get a negative sign. It becomes 0 t f of a minus dx because of dummy variable property. X, t are dummy variables. Therefore, I started with 0 t f of x dx. I end up with 0 t f of a minus x dx. This rule I am going to use in the problem which I am going to do now. Just see here. Integral, the problem goes like this. Evaluate integral 0 to 2 pi. Evaluate integral 0 to 2 pi dx by 1 plus e power sin x. This is the question given to you. At present. Just see here. The answer will go like this. Let I is equal to this much. I name it as 1. Also, I is equal to 0 to 2 pi dx by 1 plus e power sin 2 pi minus x. Since the same rule which I have proved now, 0 to a f of x dx is 0 to a f of a minus x dx. Instead of a, I have 2 pi here. Instead of f of x, I have 1 by 1 plus e power sin x. Now, 0 to 2 pi dx by 1 plus 2 pi minus x is one full rotation. Can be written as 4 into pi by 2. 4 into pi by 2 minus x is an angle in the fourth quadrant. The fourth quadrant sign is negative. Therefore, it gets reduced to minus sin x, which is 0 to 2 pi dx by 1 plus 1 by e power sin x can be written as integral e power sin x dx by 1 plus e power sin x or e power sin x plus 1. Either way it can be. This is again my I. Add 1 and 2. 2i is equal to, when I have the common denominator, I'll be able to add the numerator. Therefore, this will get cancelled fully. integral dx 0 to 2 pi x 0 to 2 pi. My upper limit is 2 pi, lower limit is 0. 2I is equal to 2 pi implies I is equal to pi. I repeat the whole process. I assume it to be I. Also I equal to 0 to 2 pi dx by 1 plus e power sine 2 pi minus x. Reason behind this 0 to a f of x dx is 0 to a f of a minus x dx. But 2 pi can be written as 4 into pi by 2. It's one full rotation in the anti-clockwise direction. Okay, 4 into pi by 2 minus 6 is an angle in the fourth quadrant. In the fourth quadrant, sine is negative. For any even multiple pi by 2 plus theta, sine of this value become, it remains the same, sine becomes sine, cosine becomes sine, etc. Now for the fourth quadrant, sine is negative, they will end up with e power minus sine x. Can be written as 1 by e power sine x. After taking LCM, e power sine x goes up. E power sine x plus 1 or 1 plus e power sine x, both will be the same. Name this is equation 2. Add 1 and 2. 2i happens to be 0 to 2 pi 1 plus e power sine x by 1 plus e power sine x dx. The whole quantity will get cancelled. Integral dx is nothing but x. X 0 to 2 pi, therefore 2 pi minus 0, which is 2 pi, therefore 2i is 2 pi, I is pi. I'll give you a generalization. In fact, if it is 0 to 2 pi, here I have one full rotation in the anti-clockwise direction. 0 to 4 pi, 4 pi can be 8 into pi by 2. It's two full rotations in the anti-clockwise direction. Therefore, 4 pi minus x or 8 into pi by 2 minus is again angle in the fourth quadrant. Therefore, it will become e power minus sine x. I'll end up with 2i is equal to 4 pi, I is 2 pi. If it is 0 to 6 pi, here I'll get 6 pi minus x. It is 12 into pi by 2. 12 into pi by 2 is 3 full rotations in the anti-clockwise direction. 4 into pi by 2, 1 full rotation. 8 into pi by 2, 2 full rotations in the anti-clockwise direction. 12 into pi by 2, 3 full rotations in the anti-clockwise direction. Therefore, 12 into pi by 2 minus 6 is an angle in the fourth quadrant. Sine is negative. Again, I'll end up with, here the answer will be 2i is 6 pi, I becomes 3 pi. Therefore, in general, 0 to 2n pi dx by 1 plus e power sine x. Here 2n pi minus x, it is an angle in the fourth quadrant again. I'll end up with e power minus sine x. Therefore, 2i will be 2n pi, I will be n pi. Our in general 0 to 2n pi dx by this will end up with I to be n pi. Therefore, if it is 2 pi, my answer will be pi. If it is 4 pi, answer will be 2 pi. If it is 10 pi, answer will be 5 pi, etc. etc. Therefore, for every multiple of even multiple of pi, if I do, it will be, I'll get the answer to be half of the upper limit. It's easier for you to remember if you remember the generalized rule also. If you use the remember the generalized rule, it's easy for you to put a tick mark quickly, A or B or C or D in your competitive examinations. Okay, in your competitive examinations, it's not a difficult task to follow. Okay, I'm trying to minimize each video for maximum of 10 to 15 minutes. I'll continue in the next video. Thank you students for patient watching.